Okay, now we'll start the Laplace transform of t to the power of n into f of t or multiplication by t to the power of n. This is multiplication by t to the power of n method. Here, if Laplace of f of t is equal to f bar of s, then Laplace of t to the power of n into f of t or Laplace of f of t into t to the power of n is equal to minus 1 to the power of n into d to the power of n divided by ds to the power of n of Laplace of f of t is equal to minus 1 to the power of n d to the power of n divided by ds to the power of n f bar of s, where n is equal to 1, 2, 3, etc. So this is the formula you people should remember here afterwards. Whenever if you get any Laplace transform function with t to the power of n or t square like that, then we have to apply this formula to simplify the problem. Okay, now we'll start first problem, that is find Laplace transform of t cube e to the power of minus 3t. Find Laplace transform of t cube e to the power of minus 3t. So how to write means just now you people studied t to the power of n means minus 1 to the power of n. So similarly here Laplace of t cube e to the power of minus 3t can be written as minus 1 to the power of 3 d to the power of 3 divided by ds to the power of 3 Laplace of e to the power of minus 3t. This is the formula according to that. Now minus 1 whole cube is minus 1 only. D cube divided by ds cube into Laplace of e to the power of minus 3t. Laplace of e to the power of minus 3t can be written as 1 divided by s plus 3. You know this formula because Laplace of e to the power of minus 8 can be written as 1 divided by s plus a. Remember this. Now according to this, if we simplify one by one, we have to differentiate d square divided by ds square. If you differentiate once with respect to s, what will happen? We get s plus 3 whole square. Okay, then s plus 3 in the numerator, differentiation of 1 is 0 minus 1 into differentiation of s plus 3 is 1. Now what happens? Using the quotient formula we did minus 1 into d2 divided by ds square. This is 0. This is minus 1 divided by s plus 3 whole square. Okay. Then again this is minus 1 into d by ds of this is s plus 3 whole to the power of 4, because square means whole square, quotient formula method. S plus 3 whole square into differentiation of minus 1 is 0 minus of minus 1 into differentiation of this 2 times of s plus 3, that is s plus 3 into differentiation of s plus 3 is 1. Now what happens? We get minus 1 into d by ds of, okay, d by ds of, this is 0, this is minus plus. Okay, so 2 times of s plus 3. 2 times of s plus 3. This s plus 3 get cancels. So cube will be there. So 2 divided by s plus 3 whole cube. Okay, 2 divided by s plus 3 whole cube. When we differentiate this, okay, using that quotient formula method again, what we get means minus 1 divided by s plus 3 whole to the power of 6. Okay, s plus 3 whole cube into differentiation of 2 is 0 minus 2 into 3 times of s plus 3 whole square into differentiation of s plus 3 is 1. Now what happens? This is 0. This is minus 6 into s plus 3 whole square. Minus 6 into s plus 3 whole square into this minus is plus 6 s plus 3 whole square divided by s plus 3 whole to the power of 6. This 2 get cancels, 4 will be there. So 6 divided by s plus 3 to the power of 4. This is your answer. This is your answer. So under this page number 1, if okay. Now we will take problem number 2 under this multiplication by t to the power of n. Find the Laplace transform of t square sin at. Find the Laplace transform of t square sin at. T square sin at can be written as Laplace of t square sin at can be written as minus 1 whole square. Here n value is 2 into d2 divided by ds square into Laplace of sin at. So this can be written as 1 only. So plus 1, because minus 1 whole square is plus 1. d2 divided by ds square. Laplace of sin at is a divided by s square plus a square. Now what happens? Once with respect to s you differentiate, because double differentiation this one time you differentiate this. So what happens? S square plus a square whole square, s square plus a square in the numerator. Differentiation of a is 0, because constant, differentiation of constant is 0, minus a into differentiation of s square plus a square is 2s plus 0. Okay, 2s plus 0. Now you simplify this. d by ds of this one, this is 0, this is minus 2as divided by s square plus a square whole square. Okay, this one. Now once again you differentiate this using the quotient formula method. Using the quotient formula method, what happens? Carefully you people differentiate s square plus a square whole to the power of 4. Okay, then s square plus a square whole square into minus 2a, because minus 2a is differentiation is minus 2a, because with respect to s minus of minus is plus 2as into differentiation of this s square plus a square whole square is 2 times of s square plus a square into differentiation of s square plus a square with respect to s is 2s plus 0. Now what happens? This is s square plus a square common, take it outside. Now what happens? Minus 2a into s square plus a square. From this one, s square plus a square taken outside already. Okay, so this is 2s into this 2 into 2as. So what happens? So that is 2 2s are 4, 4 2s are 8, 8as square. Okay, this already taken outside, divided by s square plus a square whole to the power of 4. This is whole to the power of 4. Whole to the power of 4. Now what happens? You this and this get cancels. 3 will be there. So minus 2as square minus 2a cube plus 8as square divided by s square plus a square whole to the power of 3. So this is, what is this one now? Means 6as square minus 2a cube divided by s square plus a square whole cube. This is your solution. This is your answer. Okay, this is your solution. Yeah, now problem number 3. Problem number 3. Here in this problem number 3, find the Laplace transform of t into e to the power of minus 2t sine 4t. So how to do this one now? You take it like this. Laplace of e to the power of minus 2t into t into sine 4t. This one, you arrange this one in this form. So using the first shifting property, Laplace of t into sine 4t, okay, where s tends to s plus 2. This is because of first shifting property. First shifting property, FSP also we can write. So we should know what is FSP, first shifting property. Okay, now using that first shifting property we have written like this. Now this is just like what? Multiplication by t. So multiplication by t means minus 1 to the power of 1 d to the power of 1 divided by ds to the power of 1 Laplace of sine 4t. This full at s tends to s plus 2. Now what happens? Minus 1 is minus 1 to the power of 1 is minus 1 only. D by ds of what is Laplace of sine 4t? 4 divided by s square plus 4 square, where s tends to s plus 2. So minus 1 into differentiation of this one. So if you do like this also, simplification first, 4 divided by s square plus 16, okay, s tends to s plus 2, s tends to s plus 2. Now you start differentiating this. Differentiation of this one is s square plus 16 whole square, s square plus 16 into differentiation of 4 is 0 minus 4 into 2s plus 0, where s tends to s plus 2. Okay, now what happens? We have to simplify this. What is the simplification? This is 0 minus plus 8s divided by s square plus 16 whole square, where s tends to s minus s plus 2. This is s plus 2. Now replacing that, we get 8 into s plus 2 divided by s plus 2 whole square plus 16 this whole square. Further simplification if you want you can do, otherwise you can stop it at this stage. Okay.